Welcome to Global Virtual School students. I am Dr. Ijaz Bano. This is your chemistry class, chemistry first year, chapter number 2, and the topic for today's discussion is Millikan's oil drop method. Students, Millikan's oil drop method basically is an experiment for the determination of charge on electron. After this, you will be able to understand how the charge was determined and mass of the electron was determined. Before going into the detail of this experiment, I must recall you about properties of the electron. That were the properties of the cathode rays. In that you come to know that the charge on the electron is negative, but how much it is charged, this will be determined today in this topic by R.A. Millikan's oil drop method. And in the properties you also learned that charge to mass ratio of electron was 1.75, 10 raised per 11 coulombs per kilogram. Students, this is the original apparatus that was used by R.A. Millikan for the determination of electron charge, amount of the charge on electron. This is basically chamber. Inside this is divided into two portions. Upper one has plate called anode, lower one has a plate that is called cathode, and eyepiece to observe the movement of the droplets, and atomizer just to spray the oil inside for fine droplets, and X-ray source. So this is how it actually its parts in this paper diagram. Basically, this is a metallic chamber, and there inside are two chambers. They are divided by electrodes. When this will be attached to the positive terminal of the battery, and this will attach to the negative terminal of the battery, then this will be called anode or cathode. Otherwise these are just plates, and the anode contain a hole for the movement of the droplets from here, and but this can be closed and can be open anytime. And here is the atomizer. Purpose of atomizer is just to spray. Here is the oil, just to spray the oil droplets inside it. Drop is contain a big quantity, while droplets, fine droplets, they have very low mass, and this passage is for these oil droplets. And here is the telescopic eyepiece, just to observe the movement of these oil droplets inside the chamber, because this chamber is made of metal. And there is one X-ray source just to charge these oil droplets inside the chamber. So basically its parts are like anode and cathode, X-ray source, atomizer, oil, telescope to observe the movement of the charge. And now we will see how this experiment worked, how R.A. Millikan observed the charge and determine the charge on the electron. Fine. And this is one droplet, and I am taking it outside this just for your understanding. Consider this is a fine droplet of the oil. That was sprayed inside the chamber with the help of atomizer to produce fine droplets, and these can move, and with the help of a lid, this can be closed and this can be opened. What did the R.A. Millikan in the first? You can say this battery was off. There is no positive charge on the anode, no negative charge on the cathode. When the droplet is come from anode to this chamber, it will free fall, because under the force of gravity, it has a mass and force of gravity. So this will move, its velocity will be proportional to its mass and force of gravity. So downward it will move with proportion to its mass and force of gravity, because there is no charge around it. It's just a free fall. But what did the next R.A. Millikan this sprayed the X-rays on these droplets, and these droplets get charged. They take the electrons from these X-rays on it and they become charged. negative charge, and he turned on this battery, this source, this electric field. When the electric field is on, it contains a positive charge and it has negative charge, and these droplets, now this is carrying a negative charge. Then in the presence of electric field, this is positive, it will move upward, it will move towards the positive side, or you can say the positive electrode, that is called the anode. If the electric field, strength of electric field is higher than the free fall, of course it will move upward. This is the electric field strength, E is the charge and E is the electric field. Capital E is the electric field, this is the charge. It means Rm Millikan in this way suspended the drop here by adjusting the electric field strength. And if it is moving upward, it means strength of electric field is greater than the force of gravity. So the velocity with which it is moving upward, that will be proportional to the electric field, strength of electric field minus force of gravity. So then dividing these two velocities, Rm Millikan calculated the mass on the electron, charge on the electron, that was 1.602 to 10 raised power minus 19 coulombs on electrons. And every time it was the minimum 1.602 to 10 raised power minus 19, or it was multiple of it. Multiple mean it was double of this charge or triple of this charge. So the minimum charge this droplet picked, like one minimum charge, that was due to electron, that was, it was 1.602 to 10 raised power minus 19 coulomb. Or if it is picking two electrons on it, it means, and then its charge becomes its double. So by adjusting the electric field, Millikan determined the charge on electron. The minimum charge was 1.602 to 10 raised power 19 minus 19 coulombs. And then later with the modern techniques, the charge determined on the electron was the same as Rm Millikan was determined at that time. Students, now there is a question, this is a short response question from your reference book, that now determine the mass of an electron. This is very easy, you already know charge to mass ratio in the previous lecture, that is 1.755 10 raised power 11 coulombs per kilogram, and the charge now determined by Rm Millikan, that it is 1.602 to 10 raised power minus 19 coulomb. So now just put the value of charge of electron in this, because charge mass already know. So this is the charge to mass ratio. So take the mass in this side and divide it by charge to mass, and you can find the value of mass of electron, that comes 9.1095 10 raised power minus 31 kilogram. It is a very small value, but it has that is 9.1 10 raised power minus 31 kilogram of electron. So now in this way charge determined and mass of the electron is also determined. Students, this is the question again, a short response question. How much heavier is the hydrogen atom? Hydrogen atom, you can also call this proton as compared to an electron. That is very simple. Keep the mass of hydrogen atom divided by mass of electron, because now you know it. So the ratio comes out 1837 divided by 1. It means hydrogen is 1837 times heavier than that of electron. This is just their ratio. If we consider mass of electron is 1, then mass of hydrogen atom will be 1836 times greater than the electron. It means hydrogen atom is 1836 or 7 times heavier than that of electron. Hydrogen atom is also called proton. I already told you that hydrogen contains one proton and one electron. There is no neutron. So hydrogen atom is also called proton. So if there is hydrogen atom or there is proton, these are the same things. Students, as you know, hydrogen atom is 1.37 times heavier as compared to electron. Why electron has higher charge to mass ratio? Electrons, mass of electron is lower, mass of proton is higher, but charge to mass of electron is higher. Just understand. Charge to mass. Consider this is the electron and this is proton. And consider this is charge negative and it has positive. These are just charge. And we consider electron charge is 1, so it's in negative, but charge is 1, and proton, let's suppose, is charge is 1 but positive. And just we determine proton is 1837 times heavier than electron. If consider electron is 1 mass, this proton is 1837 times. So answer of this will be 1, but answer of this will be in points 0, 0. It means charge to mass of proton is less. Why? Because its mass is higher. Because mass is dividing by the charge. When mass, wherever the mass is divided, then its answer will be lower. As so, proton is heavier, its charge to mass ratio will be low. Although electron is mass of electron is lower, then its charge to mass ratio will be higher. Hopefully, you have understand it. Question can be asked in this way: why proton has low charge to mass ratio than an electron? Then you can tell because mass is dividing, so elements having higher mass, they have the low charge to mass value. Now question is for you: why neutrons don't show charge to mass ratio? Of course, you know neutron has mass, but neutron is neutral. It has no charge. When there is no charge, then there is no question of charge to mass ratio. Students, this was all about the charge of electron and mass of electron, and we have compared the charge to mass ratios of electron and proton. And in this today's lecture, we have covered this determination of mass, determination of charge on electron, and compared it with the hydrogen atom, or you can say proton. And our next topic will be discovery of proton or discovery of the positive rays, or simply you can say positive rays or discovery of the proton.